This is Anagalactic bringing you another science presentation, the fifth in a series of brief, about 20-minute lectures, and we have gone from the proton to the electron to the Einstein field equation for gravity, and we're going to synthesize that now in order to get the geometry necessary for studying the nature of light propagation in free space, which is necessary in astrophysics in order to understand the information geometrically that we're getting from the universe. This is to get universal structure. So we're attempting to attack or assault or besiege, approach, get into, understand somehow, formulate. We're trying to understand reality. And this is physical reality, the province of physics. So this is nothing fanciful, but it's going to sound fanciful for a while, because we need to synthesize several paradoxical situations which science has encountered in its exploration of subatomic physics and, of course, in attempting to penetrate the edge of physical space, both of which present paradoxes which I have proved are reciprocally related. Now we have two relationships that we need to master, and there are three relationships that are basic to geometry that need to be understood fully. The first one, the basic one, which I have not mentioned yet, but which you are most familiar with if you're anything like an ordinary person in the modern age, the line. The line is polarized on its metric, but it's also geometrically polarized even without the intervention of a numeric system called the metric of the space. This would be linear space, which we know is balanced on zero. That is appropriate for the operator called add, and that is the only operator that works on the line. So that is called 180-degree relationship based on the Archimedean balance. Going back to Archimedes, and you can study that if you wish, in Archimedes' incredible formulation of the area under a parabola, which is a calculus equation. And Archimedes used calculus in its primitive form. Calculus is a layered concept because it's an attempt to get an approximation that can never be reached. And that is an innate limitation of linear geometry, that it cannot get curvature. That is the nature of all the paradoxes that we have in physics right now. It is a mathematical problem. I have distilled it down to its essence and solved it. And so this is a basic mathematical and basic geometrical reformulation of the basis of science itself. So this is inordinately profound. It's ultimately profound. It is, in fact, the solution. So this is going to challenge you right down to your nerve-ended meat, and you will risk your sanity. There is no evading that. I've already warned you about the dangers of laser technology, that in your own household you can burn your retina out with something that you can buy at the store that many might think to be a toy. The same thing is true of magnetism, the magnet. If you get a powerful enough magnet and you don't know what you're doing with it, you can lose a finger. Okay, the same thing is true in attempting to get understanding of a transcendental nature. What do I mean by transcendental? Is that Eastern spookicism? No. Transcendental is actually a mathematical term, and I'm going to show you today that it is also a geometric term that leads to an extremely difficult concept to master called imaginarity. And this has a physical basis. We now know, due to the work of Einstein and beyond, and largely, I'll just say without trying to pat myself on the back, I've made some progress into this area, such that imaginarity is a fundamental concept of the universe, and the universe cannot be fully understood without an imaginary space. The word space here is being used in its geometric sense of an abstraction that's in our perceptual space. Now, our perceptual space is geared to reality. That's the basis of science, the basis of rationality. It has extraordinary and fundamental religious significance that we are blueprinted to lock with the universe, to unify our minds with a universal, and here it does get Eastern, so I won't complete that sentence because that goes into spooky la-la land. But imaginarity is right there. So, we're going to have to master this now, and the way to do that is with geometry. We're going to break the Einstein field equation open, and we're going to reformulate it correctly. We're also going to solve, absolutely solve, the quantum paradox complex system. It's a system of paradoxes. We're going to get the answer to both of these inordinately important paradoxes simultaneously, although on a skew relationship, as it will be apperceived at first. Now I'm raising my voice, and I'm going to calm my voice down now. I get this way when I'm intensive, when I'm intense. And I shouldn't. I should maintain an even keel. But I'm glad that I was able to express what amounts to a quasi-emotional state in order to express to you the severity of what you're about to encounter. This is going to challenge you all the way to the limit, and then you're going to have to somehow get beyond the limit, just like a tunneling electron. Okay, so in order to break a paradox, you need an anti-paradox. I've also discovered that paradoxes, at least in physics, come in pairs. So we now have a four-part system. This is a structural system. This is part of the morphological approach, of which I am an accredited master now. I learned this from Fritz Zwicky, so there's no higher form of science. And I will now be using that and teaching it to you through the use of its application, which is the only right way to learn anything, is with hands-on. We began at the center of the universe, which you now know is the proton, and that is a fact which you must accept. If you're unfamiliar, if you're tuning in for the first time, listen to the last 3 lectures. The proton is the center of the universe, and that invokes a paradox because there's no match with the edge that has been perceived by the mind of man yet, but I have perceived it, and now I'm going to convey it to you. The center of the universe seems illogical when you say that it's the proton because it is distributed. However, each proton is a center of its own local space. So we can say that, and that should make sense. If you know anything about quantum mechanics, you know that I just used a quantum mechanical term, locality. Locality is the subject over which Tim Maudlin and Bernardo Kastrup argued on the Kurt Jaimungal show for a total of 2 minutes. And then they called each other stupid, and Tim incited this by using the word silly of Bernardo Kastrup's philosophical approach, and they're both philosophers of science, so Tim Maudlin cut first blood. But this shows the severity of this issue. They were talking about the quantum paradox and could not even meet minds, which means that disqualifies them, at least in that scenario, from being scientists at all. If you're not able to control yourself in a rational conversation, you lose. They both lost. They disqualified themselves before they even began. What did they disagree about? Locality. So the fact that the proton is the center of the universe must be mastered immediately, and I'm going to teach it to you right now with a very simple construct. Consider the edge of physical space. Currently, the James Webb Telescope is attempting to probe on behalf of all of us in science to discover the secrets of the universe by probing further and further and further and further. What has the James Webb Telescope discovered? Do you know? If you look out on the internet or you attempt to read books or go to lectures, you will be misled. And I'm not going to go into that because you can see I'm raising my voice again. Another telltale sign that I'm emotionally involved, I've got to dampen that. I'm going to do so right now. This is a scientific substance. By the use of chemistry, we are able to figure out that water can be turned into wine. You might say that Jesus taught us that, but that's transcendental, and I won't go into that because this isn't religion. But it has bubbles in it, and it's cold, and I like it. Okay, so I'm going to keep my voice down, I swear to God, okay? By the way, God doesn't care if you do that. There's only one real sin. I shouldn't do this, but I am in the middle of a break, pardon me. The only way you can really offend God, because God's just watching you to see how you're going to end up, is really all God can do. Because he's not going to intervene. The whole point is he's not going to intervene until we're done doing whatever we're doing, and then he'll decide on everybody. That's religious, I know, but hey, you come up with a better idea. You won't. Okay, so what does God not like? He said so. He said, you can say anything you want against the Son of Man, and oh my God, Ricky Gervais, oh God, everyone out on the internet, fuck God. Well, God is like, yeah, I figured that would happen. That's been happening for thousands of years. Fuck God, I hate God. I don't believe in God. God's an idiot. God. Shit. Fuck. That's okay. I mean, I don't think it's okay, but it's up to you. There's not going to be a lightning bolt that comes down and strikes you for saying something against God, because he really is not. He's just waiting to see how you end up. Because you can always repent. So what's the one thing that you can't do? You cannot defy the Holy Spirit, or you're toast. If you say anything against the Holy Spirit, which I have not actually heard anybody do, I don't think, although I'm not sure what you would do. I think it's something you have to do. It's not something you would say. Although that's involved, but I don't know how. I'm not that smart. Hey, it just got warm in here, so I'm going to take off my hat. Oh, it got down to freezing last night. Okay, I'm almost done with my break. Let me take a little sippy poo. God, I'm still like a monkey with this. Because whenever I just can't handle it. I'm just like left-right dyslexic. I've always been this way. I used to think that to my left was west. It's like, I know, age 6, but that's how I guess to my left is west. Obviously I'm a little slow. Okay, some would say retarded. Well, that's relative, my friend. All right, one moment and we're ready to go. This is going to blow your you-know-what mind, okay? But it's for your own good, so you're willing, so it's your fault if you listen further. Caveat emptor. All right, here it goes. This is what your professor needs to divulge this to you. And I think a picture's worth 1,000 words, isn't it? Well, you may hope so after the next 1,000 words. I wonder how many words actually is in one of these. More like 10,000. I don't know. I don't count. That's not something I do well. Count I actually can do. Anything else, like divide? No. That's why you have accountants. But my wife went to heaven, and she was the accountant. That's why when I've been married, I've never had a financial problem. Just give her everything. Women know what to do with numbers, money, just money. Money I have never related to, but I've kept that close to my chest because you don't want to be telling anybody that you don't know anything about money, because now they're like, really? You don't? Well, why don't you come play poker with us tomorrow night? Yeah, well, I fell for that for a long time. This, my friend, is Pilsner Urquell, which I know how to pronounce because for some strange reason I took 4 years of German. Although technically this isn't German. I believe it's Czech. So I'm probably still mispronouncing it, but I'm kind of a pedant and I like to say things. It's about the only thing I can do right is with words. Numbers, not so good. Now there's my credentials for telling you the secrets of the universe and Einstein's field equation. Don't do numbers very well, but I can talk a blue streak. Well, lucky you, huh? Yeah. Now this is remarkable. It's kind of like I'm a programmer, but the art of programming is verbal. Stanford realized that and published it, that it's not mathematical. And here's where it comes into science, that dichotomy. That if you're a programmer, people think, well, you're a mathematician. No, you're not. You're a linguist. And the same thing is true in geometry. Geometry is not numeric. And obviously, I have a gift for geometry, and that's the understatement of the frickin' millennium or two. So here's what I discovered. Pardon me, that is polite in most countries. I was raised with a tolerant mother who only threatened to hit me with a hairbrush if I belched like that at the table again, but it made my sister laugh so she would blow milk out of her nose. So I'd time it, I'd watch her, she's taking a drink of milk, and out it comes. Sam, I'm just kidding. You do hairbrush. I don't know where, she always had it somewhere. Threaten me with that hairbrush? Fuck, then I'd stop until, later. And start again. Because I'm a juvenile delinquent. Probably still am. Well, you just saw evidence of that. I'm in an expansive mood. I'm in a very jolly mood. This is the Christmas season, and I'm trying to give you the secrets of science, but I am happy. I'm having fun. I want you to have fun too, but you're not going to have fun. I'm just telling you now. For a moment. And it's really up to you, and I guess the gods, whatever you believe in, pixies, that help you figure shit out. Where do you get intuition from? Nobody knows. Well, you get it from geometry, so this is the easy path to understanding the universe. So let's begin. We found the center of the universe. It is the proton. So now we have a piece of information we can now interlock into the bigger puzzle. Since we have the infinitesimal, see the last two lectures if you don't understand what I just said. It's perfectly reasonable what I just said. If the proton, and I'm not going to say if, I'm going to say since the proton is the center of the universe, the proton is the infinitesimal of calculus fame. It is the geometric calculus infinitesimal. And that has a direct implication. We can now state with absolute certainty that that space in which the proton exists has an integral. And if you take all of the protons and consider them together, they make the gravitational center of the universe. The entire universe must have a gravitational center for this reason, that there are protons in the universe causing centripetal force, which is spatial contraction. We know from the formation of macro-scale objects such as the Earth and the Sun, that is planets and stars and even galaxies and beyond, are all controlled. There may be other forces involved, and we're getting to that, but gravity is an integral force. How do we know that? Because the Earth is spherical. We know it even better because the Sun, which is made of plasma, which is not solid, it's also spherical. Well, that requires an explanation. We know what it is. It's the proton. It's integral, protonic, centripetal force. Remember that word centripetal, because if you do, you're going to latch faster to what I'm going to say next. Because the universe has a center of gravity, therefore it has an edge of gravity, and that would be the outer edge of physical space. So now we're going to address that aspect of the paradox. And what is the paradox again? It seems to go on forever. That's impossible. I've already proved that that's impossible. That is, science has. That is, logic has. That is, pure geometry can inform us that the universe cannot be infinite, and therefore it has an imaginary component, and that is bound to the edge of perceptual space. I hope that made sense. Each and every word is important. I've been working on this for 2 years, so I'm becoming somewhat eloquent in stating things that are incredibly difficult even to state because they're paradoxes. Let me just have a second helping of brunch. So the edge of space is bounded, geometric terms, it's bounded by an imaginary space. So now we have a perceptual spherical universe that is bounded by imperceptual imaginary space. And so we're going to assign a number to the edge between those two, and that's infinity over 1. See my previous lectures for proofs of this. This is the proof sequence that you would need to know that for sure. but you can figure it out if you're clever. So this is a legitimate operation. We can assign a number to the edge of the perceptual universe, which is apparently spherical but cannot be just that. It's actually hyperspherical, and this is the way we get the definition of hypersphericity. Hypersphericity is the equivalent of 4D geometry, and I've expressed fairly clearly in the previous lecture, which got somewhat emotional and humorous, I hope, because it better be if it's emotional in science, because why are you expressing emotion in science? Well, it can happen, and I proved that in the last lecture, but I had to get across a very important principle, which is that 4D Einsteinian grid space cannot possibly figure out the universe. And you should know that by now, and if you don't, listen to the previous 3 lectures. Or 4. All right. I don't usually do this to direct you to previous lectures, but these are brief lectures, and you may want to. You may not want to. You may be willing to take a chance. Good for you. That's very, very good, but you're going to need courage to keep going. This courage has a balance because you don't want to trust a human, and I am a human, but if you want to trust me, that you need to do so in order to gain the benefit of scientific communication. But there is a form of trust involved until you get the proof. I can't take the time to give you all the proofs because this is the most difficult problem that's ever faced physics, you understand. Okay, this goes all the way to the Einstein field equation, but to simplify the Einstein field equation, it cannot be correct. It simply cannot be correct because it's based on a grid. These are linear dimensions. There's 4 of them. One of them is imaginary. It's that imaginarity that provides the secret to the success of relativity. It's an imaginary axis. We don't want that because it's linear. So, we're beginning spherically with the observable universe, the limit of which is incalculable, and so it has an unbounded edge in what we call 3D space. But we don't want to call it 3D because that's linear. We're going to call it what it is. It's spherical space with a hyperspheric edge, which has to be imaginary, and that's where imaginarity goes. So lazy 8, which we're just going to use that symbol for this infinity. This is not linear infinity. The lazy 8 should have a subscript or some indicant of which dimension it's referring to, because each dimension, whether spherical, that is curved, or straight, of which we know of 4, each one has its own version of infinity. This is critical to understand. So we don't want linearity, and so we're not using the lazy 8 linear version. This is spherical infinity over 1. That's a proportional number, which the Greeks knew are the only numbers that the universe uses, and you don't need to worry about if that's true, because I've proved that it's true. Ditto on going back and looking at previous lectures. So, in order to integrate the center and the edge, we now need to fully geometricize the edge. We've partially geometricized the center. It's definitely a sphere. That is called the Bohr atom, and when you get to the center, there's a proton, and as far as we can tell, and there's no way around this, it is also spherical, although it has a strange surface. So the proton is a magical particle, and it's the only unary particle in the universe. And you can discard completely the standard model of particle physics. It is valuable. There's nothing, I'm not saying anything against it, but it's a branch science that serves industry alone. And if you want proof of that, just check out, what does a Hadron Collider actually do? This multi-billion-dollar device that crashes 2 protons together, draining the lifeblood out of the Earth. Why is science doing that? Science is not doing that, except in one tiny department, which is of magnificent importance to governments. It's to get a source of power. And what are they doing to get inside the proton, which is what they're trying to do? They're crashing them together to see what flies out, to get a source of power. And it's there, too. It's called the strong force. They haven't found it yet. I don't think they ever will. I don't think it's a harnessable force. But if it is, it will destroy probably the entire Earth once they succeed. We don't need to worry about that because the fate of the Earth is already sealed, so that's a wash. But that is what the Hadron Colliders are doing, okay? That's why these enormously wasteful, government-controlled installations are crashing two protons together. It's to get to the center of the atom, and that's inside the proton. Now, we know now from the work of Gell-Mann, a mathematician, he got a pure mathematical solution for the proton. It's called the three-quark system, and that you can summarize in one geometric word. It is a harmonic. Remember that word. So remember centripetal force pulling in of the proton and a harmonic at the center, which is the proton. That defines what the proton is. So there's a harmonic, which is an impenetrable particle, although it can be broken apart. You might say, well, it's not impenetrable. We'll leave that paradox unanswered for now. But I think you got the gist of this. We have a center to space. We also have an edge to space to which we just assigned a number. Spherical infinity over 1. That is an imaginary number. And we just captured complexity. And I'll prove that to you. Lazy 8, spherical infinity over 1 must have a reciprocal and multiplicative space. That is proportional space. And infinity over 1 is a proportional number. That means it's not governed by add. Add only applies to the line. Multiply and divide, apply to the sphere, and it makes a closed system, a closed number system, which is a new number system that I discovered in 2022. So, we have a number for the edge, now we know the number for the center. So the proton has a number. It's 1 over infinity. And that is called the spherical infinitesimal. So the spherical infinitesimal is a harmonic that contracts space. Got that? The number at the edge represents centrifugal force in hyperspheric space. These two numbers multiply to 1. That's harmonically balanced between the center and the edge. The center is imaginary, but it's not a point. It's an imaginary infinitesimal, which is not 0. It cannot be 0. That's a linear infinity. So we don't use 0 in spherical space. It does not exist. And that, if you would, is the indictment of linear algebra itself. It fails at 0. And that's why we have massive misconstructions, pardon the pun, of the supermassive black hole is completely misunderstood. And therefore, so is the Big Bang. So this is incredibly profound, this axiomatic rebasis of geometrical mathematics. We've only had one system of numbers. That was proved by John Horton Conway in my lifetime, so you can take that to the bank. The line is numbers. I discovered the other numbers, which are the extension of the linear numbers, and that should consolidate what I said in the last 2 lectures. So that is synthetic. I hope you're following this so far, because the next step is a mind blower. The center of the universe is a distributed harmonic which exerts centripetal force, which collapses space to itself, to an infinitesimal that is not 0. And that is a number called 1 over infinity, and that's imaginary space. The center of the universe is a sphere of radius 0.8 femtometers. We have to say approximately, and I'll show you why. But that's extremely solid. That is impenetrable, although Hadron Colliders can break it apart. It does not normally break apart. A proton does not naturally decompose into smaller particles. And they wouldn't be particles even if they did exist. And they do. There's like 36 of these things that will fly out of 2 colliding protons. Those are not particles, but they have to be called that because they leave a trace in a bubble chamber. I will show you that that's an illusion. And it's actually the quantum illusion. But that's going way ahead of the game. We're getting there, but I hope that whets your appetite. The number at the edge is lazy 8 over 1. That's spherical infinity over 1. The center of the universe is lazy 8 under 1. And that makes a center that you can think of, just because we're used to thinking of that as a point. Just remember, it's a point that's not zero. It's a point with a radius that cannot be broken. Okay? So that's a proton. At the edge, we have spherical infinity over 1. At the center, we have 1 over spherical infinity. That should make sense. So you have a point and an edge. That's a sphere. And now it's bounded. And now that's what we have. And that is geometrically, it doesn't do much, but that's an axiomatic beginning. That the edge is an imaginary number, and the center is an imaginary number. But everything in between, what is that? What's in between the imaginary center, which has a radius, and the imaginary edge, which has an externality? When you multiply those together, they make 1. N over 1 times 1 over n is always 1. That's the reciprocal relationship of linear numbers. So these are linear numbers. That's extremely important to remember, because the linear numbers are the only computable numbers. And I've told you why, so we're not going to go into that. So now we have a 1. Well, where is that 1? It's harmonically balanced between the center and the edge, isn't it? So that means it's a sphere. It's a sphere whose radius is indeterminate because we don't have any actual numbers yet except one number. 1. So that's the center of the spheric number system, to the same proportion that 0 is the center of the line, 1 is the center of the sphere. But you can see there's a visual paradox. So this is where this infringes on perceptual space. So now you have to expand your mind. You have to expand your mind to see that this universe, the spherical universe which we just created, which has no exact metric yet, but it does have a center, that is a number space. And now we have the central number. It's a 1, which is a sphere. I hope that makes sense, because if it doesn't, rewind this or just give up, because you have to get this. So I'm going to make this as simple as possible. You have a sphere which has a surface value of 1, and there's nothing inside. But we're going to say for a moment that inside of the sphere does exist. Technically it doesn't, because it's imaginary, and we're going to do another mind trick which is going to introduce you to spheric orthogonality, and this is critical to understanding space-time. So we've learned some things about our new number system right away by constructing it, that the edge number and the center number, which are the two pole numbers of spherical space, these correspond to plus minus infinity on the line, but now you can see it's not plus minus. So what is it? Well, we're getting there. It's actually orthogonal, and I'll show you why. But the center number is the result of multiplying the edge numbers. When this is exactly equivalent to adding the two linear infinities, what happens when you add plus infinity to minus infinity? It adds to 0. When you multiply the center of spherical space with the edge of spherical space, those are the two poles of spherical space. They're the two poles of spherical space. The center and the edge are imaginary numbers. That's very important, because that gets us complexity. That is, it gets us sphericity. It goes right around sine, cosine, the calculus, and complex numbers. We won't need those with this number system, first of all, because there is no 0. Second of all, because we multiply the infinities out of existence. They're there, but they're imaginary and cannot be used. We will need to use those, but not until we get to hyperspheric space, which unifies the two spherical components of real space. And these will end up being space-time and time-space. And I hope that whets your appetite. Let's continue. The numeric basis of the number system of spherical space begins when you multiply the two edge numbers and get 1. Now you have the center. The center is the sphere. It corresponds to 0 in linear space, but it's obviously not a 0. It has a radius. We'll get that radius is 0.8 femtometers, but that's applying the metric to the system, which we got from subatomic physics. So we can thank them, the Hadron Colliders, everything which I say is wasteful, Not when it's balanced against this one piece of information. Actually, two. So now we have a new formulation of universal space and geometry which has never been conceived in the mind of man. I hope you appreciate where you're at right now. Let's continue to get the number system. If you use whole numbers, which I've proved are the only numbers that you can use, but we're getting to that. It has to do with the metric, but the next two numbers are 2 and 1/2, correct? See, because the center is 1 over 1. Remember, the edge is a fractional number. It's lazy 8 spherical infinity over 1. That has that little line, so it's division. The central number is another proportional number. That's what these are. They're not fractional specifically, or more specifically, they're proportional numbers, the correct numbers, the only numbers that the universe uses. The universe does not use linear numbers. Although we use linear numbers, that's the derivative number system based on pure calculus, which solves the calculus. To have 1 over 1 as the center number, which is the sphere, it has a value of 1 over 1. If you split it, you get 1 over 2 and 2 over 1. Think of the 1/2 as going in halfway to the geometric center, and the 2 is going out. Obviously, going out is going to be space. What's going in? It's anti-space. So hold that thought. We now have the number system for universal spherical space. It's based on reciprocal numbers going in and out. This is the answer to Zeno's paradox. So this will answer a sequence of paradoxes which are coming up, but I don't want to go afield. So now we have a number system that completely fills the inside of the sphere and completely fills the outside of the sphere all the way to the edge, which is undefined. It cannot be reached. The center cannot be reached. These are the two destinations of Zeno's paradox, and it proves that Zeno was right in formulating this paradox. You cannot reach the center. That is what we would think of as the point at the middle of the sphere. That cannot be reached. Not numerically, because it would be a 0 if you could reach it. That cannot be reached, and therefore 0 does not exist in the system. That solves a slew of mathematical problems that have plagued us for centuries. So this is deeply, deeply synthetic and solution-oriented. We're answering all the problems in all aspects, beginning at the center of the universe. That's why we started with the proton. Now we have the proton and all of space filled with numbers. These are quantum numbers. And that's 40 minutes, and that's enough. We'll be right back with another lecture. I hope you appreciate what you've heard so far. I hope your appetite is whetted. I hope I've given you sufficient insight so that you realize that this is of ultra-transcendental significance. We're going to solve all of the paradoxes in physics and mathematics. Stay tuned. We'll be right back. This is Anagalactic.